back and forth between physical models, analog tools of representation, as well as digital tools of representation, as well as new technologies and new ways of making. So we're kind of leveraging the fact that we're at a technological university to look at new ways in which we can conceive of and make space, while we are at the same time still delivering the basics and fundamentals of how you would understand your ideas, process your ideas, and communicate your ideas. So you're seeing a series of 3 different exercises that build on each other here for the first 3 projects of the semester. And then we get to the last project of the semester where we introduce program very specifically for the first time. It's a shelter, but we introduce this project in a way where we get students thinking about the project in two different arenas. One, what does shelter mean to the discourse of architecture and the discipline, as well as what does shelter mean as a programmed space that is based on behaviors and activities. This is a real site. Students have the opportunity to go visit this. So they are out in the context, but this is also the project for the fall semester where they get to synthesize and use all the different ways in which they've begun to communicate their ideas, understand their ideas, as well as make decisions and evaluate and assess ideas about space, light, and scale. The spring semester is basically set up the same way, but we obviously it gets a little bit more sophisticated, where there's a particular emphasis on material systems, ordering systems, and we're also building on what we've done in the past with some of our allied course content. We start again introducing various types of drawings. There were different ways in which we would use drawings through the material systems project, where they understand that drawing can be used to communicate things in, let's say, traditional architectural ways, as well as ways in which we need to sequence in how we make things, as well as using drawings in ways to think about what things can become. The ordering systems project builds on this and introduces program, where they get to implement and modify and apply and assess these systems in lieu of trying to make a space that deals again with not geometry and size, but behavior and occupation. And then the final part of the semester is a 4-week project where we introduce it in 3 phases: a research phase, a schematic design phase, and a design development phase, where we also kind of ask them to respond to a theoretical context, which we've introduced earlier in a previous course I'll talk about in ARC 110, where we're asking students to rethink the relationship of architecture and the natural environment. We start with the premise of an essay in some context written by Adrian Forty, where he sees architecture and architectural theorists as understanding the environment as something that's either a setting, a model, or a resource. David Gisson has suggested that there's other ways in which we may look at this. This is where students are allowed to kind of take their own position on it, but it's obviously through research and critique of previous lenses of thinking. What you're looking at here is one of several projects where they're being asked to kind of take a position on this and then synthesize it in the context of an actual place. This is out in Liberty State Park. So again, this is a real site. You're looking at a series of projects where we're seeing not just the final presentation boards, but you're seeing the process work as well. So you get to see that students are going through a series of iterations back and forth from using kind of analog tools, physical models as a way to understand their ideas at a variety of scales, not just to develop a model at the end of the project. And then we've also introduced the context of time into this semester, because we're asking students to consider the time and how that may play a role in the architecture in the next 100 years, given the fact that we've got issues of climate change and limited resources that we want them to also address in this project. And then what you're seeing here is a series of other studio projects, just so that you can get a sense of what's happening across all the studios. Every project I'm showing you is from a different studio, where students are asked to kind of go through this kind of rigorous process of synthesizing research, theory, evaluation, all in the context of making a building. This is Tools and Techniques 1. Tools and Techniques 1 is a course that's co-taught by myself and Gabrielle, and this year it was Miriam Abdelazim. The three of us all participated in creating this content. Tools and Techniques 1 is basically an introduction to the tools and techniques of architectural thinking. We do this through a series of exercises, but we also model behavior for the students. The course is broken into 2 different types of sections. One is a general lecture class in which all the students are together. The second part of this course is individual discussions and more seminar type exchange of ideas with a smaller cohort of the students that each of us were teaching. We introduce students to this through a series of lecture topics. You'll see those on the left of the screen. And then we have a series of assignments that we try to use as a means to facilitate and cultivate their ability to understand how to think about architecture, how to do architecture, how to communicate, how to analyze, and how to assess. The best way to really understand the kind of ways in which we do this is through this one assignment we do, which is called our logbook assignment. It's an assignment that is a semester-long assignment that pretty much chronicles the student's individual journey throughout the course and the different assignments that they've done through and their responses to the various lecture topics that we introduce them to. What I'm showing you here are samples from students' logbooks at the end of the semester, where they learn to not only read, to write, to diagram, to analyze, to sketch, to represent the information through their own individual lens of opinion, based on let's say, the tools and techniques of understanding that we have started to share with them. These are just some of the projects or excerpts from some of the pages. Again, the logbook is where students represent their ideas. They don't regurgitate the lectures and the writings that we have, or the readings that we have given them. And then Tools and Techniques 2 is a spring allied course to Studio. And let me just first say that this can't be done without John Cunningham. He's developed this course. He's the one who's actually in the trenches with this course. I co-coordinate this with him just to make sure that we're applying this content in service of Studio. John's been doing this for the last, I want to say, almost 6 semesters. He couldn't be here today. But this is where we focus on the act of making through various and advanced forms of representation. What you're seeing here is some of the descriptive geometry assignments. So I'm just showing you the evolution of one single student's work through the assignments here. And then you're going to see one of the things that this really enables for the students is the ability to not be hindered by new digital tools and their ideas about how they may be able to kind of conceive of those things and be able to represent those things. I know many times our students are very challenged by the new tools that are available to them because they don't feel like they can, let's say, draw or be able to produce things that they're conceiving of that may not always be traditional rectilinear geometry. And because we situate this in technology, much of the new digital tools that we use today allow us to kind of look at different types of form making as a way of rethinking different ways in which people may occupy and inhabit space. So you're seeing this one student's kind of progression through tools and techniques and how it's led into her final presentation board for her studio project.
Tools and Techniques 1 for MArch students introduces the students to basic workflows and techniques as tools for exploration in architectural design, a fundamental understanding of drawing conventions and the ability to critically evaluate drawings, and is emphasized to provide control over representational tools. So to develop that critical eye and fundamental architectural vocabulary, we evaluate and discuss our drawings together, and the translation of ideas between different drawing tools, mediums, and dimensions were emphasized to critically understand the boundaries of drawings. So I'm just going to quickly run through the syllabus just to explain a little bit how the class works. So it begins with an hour or so lecture, introducing historical and contemporary precedents with an emphasis on introducing diverse, non-Western, and innovative case studies. Discussing these case studies helps students develop a critical eye and understand how representational techniques have been used to communicate new architectural ideas. And assignments are set up as vignettes to give students an opportunity to practice the theoretical discussions and tutorials covered in class, as well as complement studio assignments by allowing students to use their studio projects as the basis for representational exploration. So we coordinated with the first year MArch Studio to give students an opportunity to work on that in the class. So again, we're thinking about language, drawing conventions, and how we present different ideas, thinking about tools such as Photoshop, Illustrator, and how those can create different spatial or representational tools to present a project in the best way possible, using the best representational techniques, and then also thinking about the combination or synthesis of the digital and physical world together and how we can overlap those ideas. And then thinking of iteration and not just one idea or one possibility, but thinking about multiples and thinking about which way we represent is best for a project. And then as these are graduate students, and we obviously can't fulfill everything we need to within the course, I give the students the opportunity to kind of go out and try different methods or learning new methods on their own and bringing them back to the course. And this is some parametric modeling and design. And then through discussion throughout the semester, we develop projects. And so there's a lot of critique and a lot of discussion that develops the projects further and further. So this is an example of one of the final projects. And this is another example where we're thinking about new representational techniques and developing a new way of presenting a project in the best possible way. So in this case, it was an oblique projection to kind of emphasize and kind of represent the idea of the studio project. Thank you.
In Tools and Techniques 2, we're looking to explore concepts related to design and constructions of buildings. Course will build on concepts introduced in other courses, focus on technical proficiency using digital tools to execute designs and understand how to use building data as part of the design process. So we're focusing on Revit production in this course. And taking some of the graphic languages and now starting to do some analysis on them. So we're also couching that in the studio projects. The students have the opportunity to work on their studio projects and develop the graphic languages and the familiarity with the tools. So we do some hand sketching. We look at our projects kind of in a critical way to think about how we improve, how we get more information, how we communicate using graphic clarity. So using the software, things like putting square footages on rooms, things like putting color schemes into rooms, modeling in the sense of what is the view, what is the end product that we're creating. So we're using Revit as an analysis tool. We're doing conceptual massing. We're looking at areas, volumes, solar exposures, anything that helps to inform the design, to progress the design process, using Revit as a design and a documentation tool. So moving through some of these analysis tools, and then we dabbled a little bit in VR. We have a very nice VR lounge in the library, which we took advantage of to kind of explore what it means to look at something in virtual space versus the physical space, navigating that, and kind of identifying with the familiarity, the comfort of the real world in that virtual space. So we took that through with some VR and as a presentation technique, rendering in Enscape from those Revit models and developing some deliverables such as VR walkthroughs, 360 views, and other tech-heavy presentables.
The program in the second year studio in the fall semester was a community theater for Jersey City. This is the given program requirements. There was one, the total square footage was about 10,000 square feet, and there was a maximum footprint of 4,000 square feet. And one program component was to be defined by the students, which was 1,000 square feet. So that could be a bar or a restaurant or a store or something like that. There were also program components for the outdoor space because we really wanted to think students about the relationship between the building, the theater, and also the public square around it. So the site was at the Grove Street subway stop, the entire square around that subway stop, which is a 30,000 square feet public plaza. And the students were limited to only build on 4,000 square feet. So that really forced students to go vertical and leave most of the square as a public space. But the public space was also part of the design process. So everything in red in that diagram here was part of the design. We started off the semester by looking at larger question of what is a theater, the definition of a theater, and the role of a theater in a community throughout the whole history of theater. We asked questions such as what is a theater in context of information technology? What is a theater? How can a theater connect to global community, but also to versus a local community? And what is the role of a theater in today's social, political, and economic context? The learning objectives are really built on what was learned in the first year. So they already know analytical skills, conceptual thinking skills, design skills, presentation skills. There were a lot of challenges with transfer students because obviously they did not run through our Tools and Techniques 1 and 2 sequence. So there was inconsistency in the tools and understanding in terms of conceptual thinking. But then what was introduced in this semester was really basis of analyzing a more complex site conditions. Then we introduced the regulatory requirements, accessibility, environmental impact was discussed. We also talk about structural systems, construction systems, and building envelope systems. And here you can also see the NAP criteria that were addressed. And these are three glimpses, three projects and glimpses into this project. So this is just example of a floor plan, exploded axonometric, some renderings. And this is from Matej Dennis studio. And an example from Jeffrey Rauch studio. And an example from Pino Pavese's studio.
The most important part of this was to showcase the wonderful work produced in all the 8 sections that I was able to proudly coordinate, work with talented teachers, talented students. The format, just as for the fall in second year, is to give them a site. And in this case, part of the site does not include necessarily a list of program items. The idea was to try to elaborate for the students, give them the opportunity to come up with solutions to 2 very critical issues that are affecting all of us at the time, and that is climate change and emerging out of COVID-19 pandemic. So as part of the objectives was that the students, rather than having a preset program, students were able to develop theirs. The site that was given was the current corner of our campus, Warren and Summit, where our bookstore is. And it is not just replacing the existing building. The boundaries extended all the way to our building as well as Colton. Again, program, the intention was to create or make a take on proposing some sort of a future way in which students will learn architecture. So it is related to our College of Architecture and Design program, but in so many ways the student needed to make a proposal as to how these, I guess, dynamics of learning this particular discipline or disciplines in the arts, interior design, digital design, would happen and what kind of facilities were needed. We emphasized two things. Well, actually, there were three. There's a guidance as to giving them some sort of introduction to code and element components that had to do with regulatory life safety items, but we dwell more strongly into the tectonic realm. We limit, as part of this crisis of environment, to make buildings that embrace sustainability by using actually engineered lumber techniques and systems. We resorted to explorations that were very, very much pair up with information that the students had a chance to practice in construction too. You get to hear a little bit more about that when I speak about that other course through the walls section as a tool. And also to think of design as the outcome that happens not in a linear process, but rather as a series of iterations. As a minimum, we ask the students to go through a process where, as 4 iterations, evaluate the process as the outcome more so than the building itself or the final board, even though this is what I'm going to show you. I don't have time to speak at this point, but we'll talk in the afternoon if you want about the criteria that I have. We do want to showcase the work produced in every single section, so I will go through them so that you can see the work done in Benjamin's studio. 2 students selected here was Kathleen and Grin. Again, you can see that the boards shift scales. They try to describe a process, try to describe the accuracy of the process and verification of that into site conditions, into tectonic conditions, and
Julio, we are
programmatic
running out of
conditions. I know, I'll be very quick. I think that it's worth, since this is a super jury review, that the work of every studio, I guess, to be showcased. And I do apologize for the short viewing of some of these projects, as well as the reformatting. Most students were asked to produce a long board, and I took the liberty of modifying that format in order to meet the criteria of this presentation. In construction one, which it's actually taught by Mark Best for the last 2 semesters, but I have taught in the previous semesters, we deal with construction issues, but more than anything, break up the program into addressing more than anything climate conditions, site conditions, studies of soil, foundation types, and then we concentrate on building systems that are, I guess, get to be developed or are created, or they have been made in the context of the construction industry around wood construction, about metals in construction, and we close the semester with masonry. The course that I teach, and I have just finished teaching, that was pair up with the program, the work that you just saw in studio, is construction 2, which picks up from where it's left in construction 1 and carries on information of exploring the last system that was not covered in construction 1, which is construction 1, and dwells into issues of constructions that are to some degree slightly more sophisticated. Enclosure systems, how does moisture and thermal protection plays a role into creating assemblies and detailing buildings. Vertical circulation, including life safety conditions, as well as mechanical versus physically exerting components that are part of a building. And we finished the semester by having a series of lectures that each one of them dwells on exploring how the finishing materials of our times are done, the relationship that they have as to how they were done before, and the value that they play in terms of completing what otherwise would be an integrated, I guess, design criteria of what a building and design can be. I tried to do this, and I just want to make sure that we're clear on this. Rather than just dwelling in the technical issues, I do tell the students that this is a course for architects, and the idea is to try to make in every single possible way a connection to the way in which this technical information plays a role in designing architecture, creating some sort of lyrical exposure or lyrical value into whatever assembly is done, the quality of a detail in terms of the beauty of the building. So, but nonetheless, it's kind of like a process that involves both the exposure to the technical information, the performative criteria, but trying to put it always in context of architecture. So we started with, as I said, we start with enclosure systems. We move on to the one material that it is about systems, concrete systems. We eventually move on to the moisture and thermal protection. So we start to analyze how moisture and temperature affects the performative criteria of buildings. We speak about the vertical transportation or vertical movement within buildings, both from the life safety requirements as well as from the point of view of practicality in terms of either physically exerted or mechanical systems. And as I said, we finish with interior finishes. The course, the way that this is done is the evaluation happens in a process of quizzes as well as project assignments that the students need to do. It's all done through a series of lectures. There is a book that the students can resort to in terms of different kind of structure in which the book presents the material, so that the students can also, as they do their own research for their projects, they can also find a different source rather than relying exclusively on the lectures that I present. So as a way to want to make this bridge between the technical condition of the construction industry to the value that it has in pure architecture, we cap every one of those topics with a project that gives the opportunity to the students to be able to see how this information gets to be relevant and considered in the process of making architecture. So there are capping videos that are given or lectures that are given that speak, and they're relevant to each one of the topics that are covering concrete, roofing systems, interior finishes, vertical transportations. The projects that the students are given, there are all the systems that can be, that I know of, can be done with concrete. We, this particular year, we also covered 3D printed concrete for the first time. I included that. So these get to be assigned to the students. The students get to produce a series of isometric views, wall section details. So this is an example of the work for project 1. The complexity of project 2 is that we start to pair up systems so that there is the sense of integration, technical integration between an enclosure system and a structural system that explore in construction in project 1 of multiple types, load-bearing systems, brick veneers, dimensional stone, curtain wall systems. And for project 3, the complexity even goes a notch up, by meaning that they need to include or incorporate or integrate a specific roofing system, enclosure, and structural systems, ranging from wood shingles to brick veneers, and that's all I got.
We currently have a 2-semester architectural history sequence, Architecture 210 and 211. This was the first year that I faced the challenge of taking material that had previously been covered in 4 semesters and figuring out how to essentially jam it all together, what kind of curation of the global history of architecture we needed to make, and I'll go into that more in a moment. As requested, these are the program criteria that Architecture 210 and 211, History 1 and 2, seek to satisfy. Obviously, PC4 dealing with the history and theory of architecture, urbanism, and global development. And then also learning and teaching cultures. I'm showing you a view of Weston Hall because I think that it is in our lecture hall where a critical community must be created, given that we do not have discussion sections in this large lecture class. Social equity and inclusion, that occurs in the lecture hall in terms of the mutual respect that students develop for each other, but also it's something that I attempt to introduce across all of the lecture content. Our first course, Architecture 210, goes from the Stone Age up to the Age of Empires. I'm showing you for both classes the first and the last projects that we deal with. In 210, dealing with the earliest notion of human settlements and humans making community, and then ending with the Age of Empires, in this case showing you a view of Isfahan during the expansion of the Persian Empire in the 17th century, when we're dealing with a very, very sophisticated global network of trade, as well as sophisticated urban planning that extends to the proliferation of residential typologies, urban typologies, and of course, given the dominance of the mosque there, religious typologies as well. This is continued in Architecture 211, which I kind of like to call my Anthropocene semester. We kind of literally pick up where we left things off in the 16th and 17th century, dealing with the way in which empire gets translated into colonialism, colonization, settler colonialism, and the Enlightenment. We begin the semester with conquest and the slave trade beginning in Africa. We end the semester dealing with that which is recent enough that we can consider us coming up to the present, distant enough that we have a little bit of ability to assess it. So in this case, starting with the Cape Coast Castle in Ghana and then concluding with the Morphosis San Francisco Federal Building, completed in 2007. And one thing to note, especially in Architecture 211, woven into each semester is not just the lecture content, but also primary readings. In this case, Stan Allen's Terminal Philosophies, which is introduced at the beginning of this lecture so that students can understand almost in a kind of historicized manner the way that the computer began to shape architectural discourse at the very end of the 20th century and into the 21st. Our course, as I already indicated, it's a lecture course, 2 lectures a week. The content of those lectures is tested in a kind of low stakes way with weekly quizzes, open book taken via Canvas. This allows students to just make sure they're kind of keeping up with the content and at least beginning to assimilate the material. We also have a midterm and a final, but the main project of the semester is one that's developed over a series of years. It's called the Portfolio Project. It asks students to select, and you can see the overview and the objectives of that project here. It asks students to select some things that I highlight as required works. In any given lecture, we might look at, say, 10 different projects or sites, but then really focus on 2 or 3 of them. It asks them to select among those projects and to, in essence, represent them in the form of written and visual analysis. I know Kelly wanted this to be celebratory, but I couldn't help but show you 3 not celebratory projects here on my first slide. I think it's important to note that the work that students produce in second year studio is of a significantly higher quality than the work they produce, at least in their history and theory allied courses. I'm showing you some work here that, as you can see, is utterly lacking in sophistication and is undoubtedly not a reflection of the skills of the students, but the amount of time they put into it. This is a critical problem for our students. If it doesn't happen in the studio, they tend to somehow think it doesn't matter, or perhaps they simply think that the history of architecture doesn't matter, though how they imagine they're going to design buildings without studying other buildings is something that always boggles my mind. To move on to things that are much better, 4 sheets selected from Architecture 210, demonstrating the kind of range of written and visual analysis that the students produce. In each case, they're asked to develop a theme for a project, which will allow their, hopefully, both written and visual analysis to connect to that theme. In the case of the upper right, this student chose the theme of circulation and dealt with that quite clearly throughout all of her projects. As you can see, sometimes what students think is analysis is really just labeling things, but we continue to work on that. The goal here is not to have them write a long research paper, but to have them take seriously the kind of short form writing and diagramming that they're going to be called upon to do as architecture professionals. Those from Architecture 210. And again, you can see that this isn't necessarily about sophisticated graphic representation. Hand-drawn annotations are absolutely fine. The goal here is to develop content. Quite frequently, students will spend a whole lot of time reproducing themselves a set of plans or elevations and then not doing any analysis. And I lost track of how many times I'm constantly saying a plan or a section is not in itself analytical. It is merely representational. As we get into the second half of the semester, the second half of the course, Architecture 211, you can see in some ways, because the students are now more comfortable with it, the analysis is becoming more sophisticated in terms of dealing with design, composition, materials, context, and of course, cultural meaning. Here showing a range of projects from the second half of the 20th century, well, actually, no, across the 20th century, ranging from the United Nations campus to Peter Barron's turbine factory. Our students are capable of a high level of sophisticated analysis when they give themselves the time to do it. And I believe that's my last slide.
The third year studio sequence, Studio 5 and Studio 6, made, again, a climate change an important aspect of the studio agenda. We follow the AIA 2030 challenge and the resources on their website to expose students to the challenges we face as a profession. So students engaged relevant issues through case studies, research on environmentally friendly materials and construction techniques, such as timber construction or modular or prefabricated methods. They looked into water collection and reuse, energy harvesting, inclusion of green surfaces, and what that means in a context of designing an architectural project. And within this framework, the fall semester students designed the housing project and were asked to think about new models of living influenced by contemporary challenges in the society and issues of affordability and equity. And in the spring semester, the focus was on an institutional project. Students designed a performing arts education and community center and were asked to think about its place and agency within the city and community. Now, students used the same site for both of these projects. And what you see here is the site. It is near New Jersey Performing Arts Center and JPAC. And students were asked and expected to analyze this site and to take into consideration from the very beginning both of these buildings, even though second one was only designed in the spring semester. So both studios examined the scalar, systemic, and material aspects of the built environment. They looked at material and technical complexities of the human environment and the impact human constructs have on urban environments. We have guided students to focus on the following: clarity of design intention, possibilities for ecological thinking, use of less carbon intensive materials and building techniques, understanding how building elements come together, engagement with the urban context and the public, and spatial and programmatic innovation. So we asked students to articulate through diagrams the architectural thinking and actions employed in the development of the concept. We asked students to look for the possibilities for ecological thinking and explore green surfaces and roofs, inclusion of photovoltaics, water harvesting, and how building envelope can serve to mediate the climate or produce food, and at the same time be a social space for residents. Use of less carbon intensive materials, we kind of guided students to think about CLT and mass timber construction, and also to think about modular and prefabricated construction, which really kind of goes hand in hand with CLT and mass timber construction. We, when understanding how building elements come together, students produced wall sections, axonometric drawings, and diagrams, and structural diagrams, as well as large-scale models of the small section of the building. Engagement with the urban context and the public asks of students to create spaces that engage the street, that offer outdoor performing areas. In the case of Performing Arts Education Center, we ask students to think of other kind of outdoor gathering spaces, examine the link between interior and exterior, and really design the open spaces of the site. Spatial and programmatic innovation came from sectional studies and deeper understanding of the program. And even though all of these issues were addressed in both semesters, fall semester really had a stronger focus on the site analysis and site strategies that ask students to plan the site for both residential and future performing arts education and community center buildings. And the spring semester played up technical and regulatory aspects of the building. Students were expected to integrate structure. As you've seen, they also were expected to engage building codes, building systems, and findings from climate and daylight and building energy analysis also had to find a way into their design proposal. Students also were required to use Revit in this semester. So most interesting projects were, of course, those where students were able to move beyond the scope and requirements of the project.
It's about structures 1, the architecture 303, and structures 2, the architecture 304. These are the required texts and the references. Structures 1 is an introduction to structures. So at the beginning of the course, we cover the fundamental principles of statics and strength of materials. So there are some little calculations to do. After we're done with that first part, we go to the second part of the course that covers the traditional structural systems and examples of famous buildings and structures that illustrate the various structural systems and concepts. In Structures 1, we also do a project using Revit, which is a steel building project. The purpose really is to introduce the students to the structural features that are in Revit. When they come to Structures 1, most of the students don't actually know how to use Revit, and they certainly don't know how to what the structural features of it are. So I think they're finding it helpful. So there are no calculations involved in this project. It's just the modeling of the building and how to use the various functions, like how to place beams and girders and beam systems and so on. So this is the content of the course. We go over the different types of steel structural systems. Then we do some exercises to teach the students how to lay out a typical steel framing plan for floors or roofs using various structural systems. And after that, we cover the wood structural systems, including the structural composites like the glulam, the LVL, the PSL, the structural insulated panels, and covering also the CLT. We look at slides of different buildings using these examples, and then we do exercises again using wood framing plans of various configurations. Then we go to the reinforced concrete structures, and I talk about the traditional concrete structural systems, and precast and pre-stressed concrete as well, and we cover examples of concrete buildings and structures. There are some instructional videos in this course that discuss some of the topics that we talk about. We also do exercises to teach the students how to lay out a typical reinforced concrete framing plan using the various deck systems. Then we cover briefly the structural concepts that are used in bridges. As you know, a lot of these concepts are actually used in buildings now. There are many structural concepts that originated in bridges, like the use of cables that are now used really in roofs, for example, with different cable systems. I go over the couple of interesting structural ideas in the design of the Gothic cathedral, like we go over some examples like the groin vault and the flying buttresses and all that. Then we talk about tall buildings, and we look at various examples of tall buildings, with the focus also on lateral stability, which becomes very important in skyscrapers and tall structures. Then I cover some examples of monuments and towers like the CN Tower and the Gateway Arch. And we go over some examples of domes. Some of them are ancient domes and some of them are modern domes, to be able to compare how domes were built in the past and compare that to how they are being built today. Then at the end of the course, I talk about some complex roof systems and examples that use cables and light tensile structures. For structures too, the focus is more on the structural design and the structural design calculations. There's also a section in the course that deals with tall buildings and lateral loads, and here an example from the Palisades Mall in New York that shows the use of diagonal bracing here, which is an example of some of the things that we explain in this course. There's also a section that deals with trusses and how to analyze trusses. Then we cover the design of steel structures with some calculations where students learn how to design steel beams and steel columns. And then we move on to a project, which is actually practical assignments that will let the students basically apply what they've learned regarding steel design. The section of the course deals again with tall buildings and lateral loads, but this one goes into more, it's actually a little deeper than what we do in Structures 1. And here you have an example. I show a lot of slides that illustrate the various structural systems that are used for wind design and seismic design. This is here a photo that I took a few years ago in Salt Lake City, which really a perfect example, in my opinion, of seismic design using braced frames that are all left exposed. So after we are done with the design of steel beams and steel columns, we talk about steel connections, open web joists. I show the students how to size open web joists using the design tables that are provided by the Steel Joist Institute. We talk about metal decks, structural steel connections, and then we work on that project. At the end of the course, we have a section that deals with wood structures and how to design lumber beams, for example, and some case studies, the Seattle Central Library, the Walt Disney Concert Hall, and the Milwaukee Art Museum edition by Calatrava. Then there is a little bit of concrete material at the end of the course that cover the main ACI code requirements regarding the design of site cast concrete. I go over the different types of foundation systems and retaining walls and why retaining walls can fail and the different modes of failure. This is a list of structural electives that I teach in advanced structures, structural applications of BIM, resilient structural design, which is wind and seismic design, and cable and tension fabric structures. This is the Structures 2 project. So here the focus is to lay out a structural system for a simple structure, use Revit to model it, and then do structural calculations using a computer program, the Vitruvius project. So highlighting here some typical elements that I want the students to calculate with the computer program. Students don't know how to use the computer program, so I record some video tutorials to show them how to do the Revit work and also how to do the calculations. I have an example here of a student project, which is a good example. These are calculation pages that are, outputs of that computer program, the Vitruvius project. So they're calculating here different types of elements. This shows the structural analysis with shear and bending moment diagrams as given by the computer program. So the students here calculated all the elements that are required, and this is the modeling with Revit. Again, the focus in Revit is really on the structural functions of it and what they can do with that. So there is an introduction to that in Structures 1. In Structures 1, it's really simple. We don't do any calculations. They're just being introduced to Revit and how to use these features.
Good morning, everyone. Good to see you all today. And I am going to talk about environmental control systems, ECS 1 and 2, and I will do my best to make it in 6 minutes. So ECS 1 and 2 address the same NAAB criteria, such as PC3, ecological knowledge and responsibility, and SC1, health, safety, and welfare, and SC4, technical knowledge. So in terms of the topics, ECS1 covers passive environmental control systems, which are architectural solutions. So for example, in this course, I'm talking about fundamentals on thermal comfort and how to perform climate analysis, how to design an energy efficient thermal envelope, solar shading, passive solar, passive cooling, and how to achieve visual comfort and daylighting system design, and lastly, renewables. So once we optimize the building with passive systems, now we can integrate energy efficient mechanical or electrical systems into our design for human comfort, health, and well-being, which is covered in the second sequence of ECS, which is ECS2. So ECS2 covers active environmental control systems such as HVAC, heating, ventilation, and air conditioning system in terms of its basic operation and types, an electric lighting system, building electric system, acoustics, plumbing systems, and lastly, a fire protection system. And I use the same textbook for both courses, which is mechanical and electrical equipment for buildings. And I also introduced some other major textbooks in the subject area and online resources and current industry standards. In terms of the course format, they are set up in the same way. So we have weekly readings, lectures, 1-minute papers, and labs to reinforce the lecture concepts, assignments, and exams. In addition, we have special components such as a software workshop for ECS1 on performance-based design, and an HVAC field trip for ECS2. But this semester, I was not able to organize this field trip, which was impacted by pandemic. Both courses also share the same assessment. As you see here, the 3 exams count a lot, which are open book, open note. Other than that, I have class activities, 15%, and weekly assignments, 25%. And unlike the studio project, I have multiple assignments over a semester, focusing on a specific subject. and they have about 1 week to complete each assignment. And by nature of topics, these assignments involve some calculations and numerical analysis. And for many of them, I am trying my best to ask my students to use their studio project to perform the required analysis. And because of the time limit today, I will just talk about only a few assignments as an example in the next slides with best student work examples. So first, this is ECS1 climate analysis assignment. In these assignments, students are asked to perform a climate analysis for their studio project using climate consultant software. And they are also asked to explore some climate appropriate design guidelines using some online resources such as the 2030 palette. And finally, they need to provide a discussion how their climate analysis informed their early design decisions. Next example is ECS1 shading assignment. In this assignment, students are asked to present an analysis of shading strategy for their studio project. So they need to first define their shading requirements on the SUMPAS diagram, which should be based on climate analysis. And then use a shading mask protractor to demonstrate their proposed shading strategy. It's going to work as intended. And lastly, they need to show them intersection with the summer sun, winter sun with right angles, and of course, a written description of their strategy. Similarly, in ECS1 passive heating assignment, now students are asked to present an analysis of the passive heating strategy for their studio project. So for example, they need to think about how to properly size their passive heating system, not to overheat the space, and they need to show them in their plan and section drawings with respective labels. Now, let me talk about ECS2, again, the active systems. So in this example, this is the ventilation rate calculation example for their studio project. So they are asked to calculate and compare ventilation rates for 2 different space uses of their choice. And in that way, they can better understand the factors affecting ventilation rate and consequently indoor air quality and energy use of the building. And they are also asked to rerun the same calculation with a more advanced air distribution system of their choice to quantify the savings. This is ECS2 assignment 2 psychrometric analysis. In this assignment, students are asked to analyze the air inside our heating and cooling system using psychrometric chart, and also manually calculate the amount of heating and cooling required in the process. So in that way, they can better understand how they are calculated in building energy modeling software. And this is the last example assignment I have today. So in this assignment, students are asked to estimate how much spaces are needed for their HVAC systems and schematically present their locations with labels. So for example, this student found that she needs about 1,000 square foot for the chiller and boiler plant located in the basement of the building, and about 2,000 square foot for fan rooms, which are equally distributed between floors. And of course, the rationale is provided in terms of the program, noise, and control issues.
Landscape and Urbanism is a course that was developed by Tom Navin, and also taught by Tom Navin, and was recently taught by Jennifer Bolstad, and both of them are not available today, so I fill in with them and make up some time. So Landscape and Urbanism is a course that is about urbanism and landscape, as the title already says, but it's also about the relationship and the intersection between the two. Students are learning about landscape design in relation to the human condition, and they develop an understanding of how the design of the constructed urban environment is directly tied into and affecting the global climate, the environment, and environmental health. Students will learn about access, they learn about topography, they learn about surrounding buildings, they learn about natural systems, and adjacent functions, and they also learn about zoning. That's my understanding of like what is currently covered in this course.
Okay, so Mark, Bess, and I are going to present a professional practice 1. We're going to talk real fast. Mark's going to do professional practice 2. So practice 1 is programming and project development, and it is answers to a whole host of NAAB requirements, but I think primarily it's focused on the architectural licensing exam requirements for programming in a variety of ways, and we calibrate it towards that. We use traditional textbooks. Problem Seeking is the sort of textbook for programming. It's in its 5th edition now. It's getting a little stale, and we sort of take that up in class, and then we have readings from the handbook. But it really is a hostings class, so that once a week, I bring in someone from outside the profession, and this exposes students to a pretty wide range of different practice modes. And programming is very much a qualitative and quantitative process. We look historically at the programming influences for Salk Institute, Bell Labs, and Grace Farms, and focus on kind of building efficiencies, net to grosses, but we also look and unpack regulations from the smallest of the private covenants to the largest federal levels. We derive kind of modules through analysis. There's a whole focus on sustainability, both the good and bad of the rating systems that are available out there. And there's a special focus on finance, cost estimating, discount cash flow analysis that gets applied to what students do. We unpack the AIA contracts that specifically relate to programming, with a real emphasis on integrated project delivery, which is kind of the future. And it really tries to take the black curve here and move it further to the left to influence design early on, taking advantage of BIM and other practices like that. So the requirements for the class break out. There are 2 exams, a midterm and a final, and I'll walk you through the different assignments. We initially start out by basically asking students to diagram where they grew up. We then kind of do reverse programming, where I give them CAD files of NJIT buildings, and they have to kind of figure out the loss factors and the efficiency factors based on that. And then we dive into a pro forma program where we work on 6 sites in the Ironbound that students need to put about 100 units on about an acre site. Then they do a series of site analyses. They unpack the development plans and the zoning for that site. They look at comparables using the databases provided by our real estate partners in the class to develop diagrams that come to building models, and then establish kind of the program diagrams. And the end of it really is a building analysis that is financial, so that we kind of look at what is the yield on cost for the project, how it performs financially based on design decisions that students have made. And that's my 3 minutes. I'm going to turn it over to Mark.
My course is the second part of the professional practice sequence. And what I do in this class is to really, a lot of it is about relationships. A lot of it's about how architects working in the professional realm relate to the client, how they relate to other firms, how they relate to the government. We talk about how businesses are started and run in terms of practice. We look at the differences and commonalities between different size and types of firms. We look at the legalities of the requirements for architectural practice, amongst many, many other things. On the screen, you'll see the one of the texts that we use, the Paul Siegel book, which is Professional Practice, which is one of my favorites. We have others. We have lots of readings that I post on Canvas and other texts that they look at. The NAB student and program criteria are also listed on the screen as well. Forward this. Let's go. There we go. Okay, so we start out with in the course looking at the profession of architecture, generally speaking, some of the influences that Americans have with regards to architects. We go back and kind of trace before there was a profession of architecture, because architecture as a profession is relatively young, and move forward from a historical standpoint. We also take a look at these individuals and groups that we call clients. We speak about the idea of a patron versus a client type. The advent of a more modern type of client where we now have a huge population of individuals to kind of serve. Spend a bit of time looking at the difference between public and private clients. And we talk about how people make decisions about selecting architects and what some of the situations are that they have to assess because most people don't have the opportunity to work with an architect during their lifetime. We kind of transition that first part of the semester also with firms, and we look at firms from a lot of different perspectives. We look at Dana Cuff's writings about the belief systems that are kind of inherent in architectural firms and how they relate to the actual practice. We look at firms relative to size and firm culture. We look at what it takes sometimes to start a firm. So these are some of the things that we start out at the very beginning of the semester. Then we kind of transition to a next phase, which I kind of group together project delivery, different types of agreements that we would have. And then we start taking a look at a couple of documents. So project delivery is something that I really like a lot. We look at some of the characteristics that impact the different types of delivery systems, whether it be design, bid, build, design, build, construction management, and the two different types of construction management as agent and at risk. And we do kind of circle back and have that discussion about integrated project delivery systems. We take a look at two AIA documents, the typical B141 owner-architect agreement. We really try to understand what an agreement is, what they're about, why we need them. And in that discussion, we start looking at fee structures, how architects determine fees for services, what some of those standard services are. And we have a couple of assignments where they kind of look at, generating fee systems. And then we transition over to the AIA 201 general conditions, which really the way I package that is almost like the handbook for construction. What do we do during the construction phase? Why is this document so important? We unpack kind of the major focuses of it, such as bonds, insurances, submittals. We look at payment applications. We understand what substantial completion is and how architects need to function during those roles, during those time frames. Then the next kind of package, which usually occurs right after, right on or around the middle of the semester, we look at regulations and we look at the history of zoning, what brought us to where we are these days. We do kind of dovetail with some of the information that Darius had presented in the previous semester. We take a look at planning and spend a little bit of time looking at New Jersey as a very unique environment in terms of planning. The development of suburbs here in New Jersey and looking at kind of the intrastate relationships between New Jersey and New York. We also take a look at the NCARB and NAB and ARE requirements, which is mandated obviously by the NAB, that has to be presented every semester. So we walk through the AXP process. I encourage students to consider signing up and show them how they can navigate that system. And they become familiar with some of these key organizations that you see on the screen, some of which they're familiar with, others they're not. And then we take a deep dive into building codes for several sections. The first section really looks at the history and background of building codes as they were developed over time. And then we take a longer look at codes in general. Here's an example of an assignment related to building codes. I'll give them, for example, a series of floor plans, and we'll talk about egress and how we can calculate travel distances, occupancies, occupant loads, egress widths of stairs and corridors, allowable heights, allowable stories based on use group and construction type. So on the left, you see the kind of what I would give to them, and on the right, they would have to fill in that chart that you see on the right once they kind of dig deep into different sections of the building code. So we look at the code from kind of a historical context. We look at it from a code analysis context. Then we spend a significant amount of time looking at egress. And then as we move towards the end part of the semester, I package ethics and liability together. We kind of look at ethics from a couple of different perspectives. In a general sense, the public versus the private, belief systems versus actions, and then kind of translate that into how it impacts architects in our role. We look at registration statutes that are endemic to, for example, here in New Jersey, the Division of Community Affairs. We jump on the DCA website, the State Board of Architects. We look at the AIA Code of Ethics. We look at antitrust in terms of business relationships. And we do a lot of case studies and talk about actual situations and how students might perceive themselves being in those situations and what decisions they might make. When it comes to liability, we look at the standard of reasonable care. We really take apart what it means, what negligence means, and how that's actually determined. We talk about risk associated with our agreements, or the risk associated with using new products, for example, in the architectural world. And again, we look at other case study situations. Then we spend a little time looking at construction documents and specifications. I tend to not spend a whole lot of time with the drawing part because they do have some familiarity with that vis-a-vis working in studio and other classes, but I try to have them understand that the drawings are just one part of a total package of what the deliverable is to your client. And then we take a deep dive into specifications, looking at how they're developed, what they are, how they're used, why they're important. And as you can see on the screen, some of the things we talk about: allowances, alternates, unit prices, divisions, sections, section formats. And I share with them automated tools for developing specification sections, and show them how they can develop one or some sections of their own using some of these automated tools that are online. And then we kind of wrap up the semester with a discussion on contract administration and project management. And in doing so, we look at the architect's role during construction and how we have to be very clear about our relationship with our clients. We have to be fair with our contractors. We have this kind of interesting tightrope to walk between managing both. We look at payment applications once again, and I give them a specific example. We look at RFIs, how submittals are processed. All of these different things that we kind of address during contract administration, how disputes are resolved. And then finally, project management, I kind of end up with that. We talk about who this person is and what they do on a regular basis, what their responsibilities are. We spend a bit of time talking about leadership. We talk about why architects are automatically cast in the role of leader, and what are some of the qualities of leadership and how you can develop that as an individual, either through self-help or through experience. I try to have the students understand how important it is to, when they get into a work situation, to ask questions and put themselves in a position that would help them succeed. Finally, we look at things like scheduling, managing staff, managing teams, managing consultants, and that's kind of a wrap for me.
Talking about first semester Masters of Architecture Studio. First, I'd like to say that the studio is synchronized with the Tools and Techniques course. Last semester, Benji taught it, and it was a pleasure to work with him. The assignments between the Tools and Techniques course and the studio were synchronized, and I think that worked out really well. Realize that most of the students coming into our program do not have a background in architecture. So they're starting anew, with no real knowledge of architecture other than what their own life has been. So in a way, what we're trying to do is compress the first year of the Bachelor's of Architecture program into one semester. And in many ways, it's similar. In other ways, it's different. First of all, we are immediately addressing context, and we're immediately addressing program. And we're doing so through staging a design project, which is done twice. We have required readings, language of architecture and analyzing architecture, which are kind of the basis of the understanding of what architecture is and how one goes about thinking about it. The project itself is 16 craft guilds. So it's a repetitive system of very, very small buildings, if you would, fundamentally one space. And then the studio is addressing 4 different architectural characteristics. I hope these are things that the students are able to use throughout the rest of their academic and professional career, and 3 separate design theories. And I'll talk about that a little bit in a minute. The first, the site, both projects exist on the same site, and they have adjacencies. One part of the site is very, very linear, and we're starting off with looking at 3D conceptual models as the basis.
Steve, we cannot see the slide advancing. We're still looking at the first slide.
I know, I haven't advanced it yet.
Oh, okay, sorry.
Okay. And we're starting off with cubes of various sizes and colors. We're starting off with physical model making in the context of physical site models. Every student has their own site model. We're deriving drawings from those physical models. We're doing sketch overlays, and eventually we're using Rhino, obviously, to document the cubes, the site, and eventually the design. The second design project is a field site. It's an area. We're starting off with 2D images and drawings, developing a concept, and then eventually designs from that, kind of extruding design out of the 2 dimensions. Again, we're developing drawings from the physical models. The areas that we're looking at, conceptual areas, are the ideas for the site, a site that's linear, dense along the Arno versus rectilinear, open and large. We're looking at monotype versus monotype because of the multiplicity of the functions, 16 different units. Heavy or light, which is both psychological and technical. Horizontal versus vertical, a composition. And the design theories of architecture, which is picturesque, classical, or network based. Excuse me a second. Okay. So the premise of the site is that Florence wants to distribute its traditional crafts amongst the city, to distribute tourism from the historic center, to take on the entire urban context. The site, as you can see, is a piece of land that juts out into the river. It has medieval origins. It's very precise in its characteristics. It's unique in its characteristics. It's both separate enough from the city that you can do anything you want in a way, close enough to the city to begin to be part of the discussion and argument about what the architecture should be. The program is 16 very, very small craft spaces, in which each craft space has a different kind of craftsman that's associated with a different kind of workplace, different kind of environment, tools, techniques that are associated. Part of the program is to develop a streetscape and piazza or public space that's associated with the guilds. Another part of the program is to consider the natural landscape, whether it is man-made or naturally occurring. And then the monotype has to do with the degree to which each of the 16 craft guilds are identical, or are they different and for what reason? Or are they radically different because they're expressing different ideas, different aesthetics, different methods of working? We're looking at heavy architecture as a way of, in all its forms, isolating, certainly relates to the urban context of the history of Florence, or light architecture, which is adaptive, climatic responsive, more maybe contemporary in technology, more dependent upon climatic relationships. We're looking at heavy horizontality and sequence, particularly because of the linearity of one of the sites. We're looking at verticality because the site has a characteristic in which it could be certainly a landmark within the city, or that each of the artists may want a unique condition rather than be part of a group. We're looking at a vernacular, picturesque, having to do with the origins of maybe medieval urban landscapes. We're looking at the formal ideas of composition having to do with the classical and the Renaissance aspects of the city and architecture. And we're looking at the aspects of networking architecture relating to the distribution and integration of natural landscapes and urban systems, and the idea of distributing the art amongst the city. So here's a few examples. These are, I'm going to show 3 examples. They're pieced together. They don't represent the students' final presentations, but you give you an idea of some of the work. Again, these were half semester long projects. In this case, they're starting off with a 2D image, just determining what that image means. How could it be applied to the site? How is it positioned, scaled? What does it mean programmatically in terms of the climate, in terms of the context, in terms of the program? How do you develop it into a three-dimensional system? In this case, carrying over the use of cubes. Cubes having the advantage, obviously, that if you're working with cubes in the context of a site model, you can be very deliberate, you can be exploratory, you can do things randomly, you can do things consciously and deliberately to try to accomplish a specific objective. Students can work interactively. They can look at what the models are in place, and the modeling process is going on in studio, interactively with other people, alone. We're photographing the models, we're drawing over those photographs, and because it's cubes, it's dimensionally accurate. If it's 20 by 20, we know it's the size of a 2-car garage. If it's 10 by 10, we have some idea how big it is. So there's a lot of meaning and ease of transition of using the cube. It also makes it very easy to make the transition in the earlier parts of the semester to begin to develop digital models. So we're trying to combine all media together, whether it's hand sketching, digital model, photography, and perspective. This project started off with a 2D image and began to develop it into a 3-dimensional composition for the site and for the distribution of the program and for boundaries of privacy and public space, and began to develop the differences between one craft studio and another. And this is the last example, starting off again with a 2D image, developing into 3D form, looking at it as whether it was a heavy building, lightweight, adaptive, active, movable, or stationary, isolating, looking at the relationships, in this case, between the nature of the boulevard to the north and the Arno River to the south. And part of the responsibility, of course, was to develop in greater detail the floor plan of the craft guild, which had to do with the layout of a workplace, the area for display, the area of storage, and a place for an apprentice to reside for a 6-month period of time. So we dealt with the project at 3 or 4 scales, ending at the scale of more specific functionality of what is the difference between a workplace of someone who's making jewelry versus a workplace of someone that may be working with leather.
We called this project MoCA NYC. We cited the project along Newtown Creek in East Williamsburg, Brooklyn. Chose this site because I thought that it was a particularly good site for dealing with some complex urban issues. The studio explored the creation of a unique public arts institution with an outdoor public plaza within an existing building shell along an industrial waterway in a dense urban environment. It was 100,000 square feet of interior space, including exhibition, cafe, arts incubator, and arts education spaces, as well as 45,000 square feet of exterior space, a combination of public and private space. We wanted to deal with urban public space with the sort of unique conditions required for an arts institution, as well as sort of have a conversation about zoning and industry and land use in urban environments. I am also not, oh, there we go. Okay. So in terms of objectives, the design studio meets all of the NAB accreditation requirements with a particular emphasis on PC2, PC3, and PC8. We started the semester by doing a deep reading of Lafave, The Right to the City. which if anybody is familiar with that text, it's quite dense. And I think it was sort of an interesting way for the students to come into the studio. And then we followed that up with some other readings. David Harvey's Right to the City, which is a little bit of a response to Sollohub. And we also looked at urban design and how spaces are shaped from a European perspective, reviewing Gothenburg, Sweden's River City View, their plan for development of urban spaces, which is very much focused on design from eye height, and also their integrated child impact analysis and dialogue requirements for every project, as well as the UN Sustainability Development Goals. We also talked about biophilia and Gell's 12 quality criteria for public urban spaces. We had a client for the studio. I thought it was important. I think that architectural presentation is sort of interesting because it's always a question of who we're presenting for and who we're speaking to. And so we invited artist who grew up in East Williamsburg, Bushwick, to join us as client for the project. And she came, we had a tour with the curator at the Amont Foundation in Bushwick, which is just a few blocks away from the project site. She joined us for that tour, and then we sat down with her and talked a little bit about sort of the future of art museums and the relationship of the museum to the neighborhood there, and sort of art space development as a threat, being seen as a threat to neighborhood residents, and what that would mean for the way that the students should consider developing their public space and the museum itself. And then during that visit to the Amont, we also visited Lauren Augustine, which is a high-end gallery in Bushwick, as well as the Whitney, to kind of really see what a high-end arts institution looks like. And then Tabitha joined us again when we visited 1717 Troutman to see artist studios, because part of the program was an arts incubator. And I wanted them to see the realities of spaces for arts production. So we had our midterm review pin up there in the artist studio. And then Tabitha joined us again for the final presentations. And it was very interesting. We also had, two very seasoned architects, one who designs art museums on a regular basis, and one who has been very much on the business side of things. But it was interesting to have sort of real world comments for the students. I think as an architect, I was a little challenged my first time in firms interfacing with real clients that speak a little bit of a different language than us architects. So some images from our site visits here. Our studio process, I wanted to really give them a strong foundation in sustainability, and I'm a bit of a sort of analog sustainability geek. So we used Design with Climate and Sun, Wind, and Light, and they created diagrams showing the ideal formal building response in our climate, so that they could understand what the sort of perfect solution is. I don't know if you can see my cursor, but that's what you're seeing here is one of the students' presentations of that. And then we followed that through the semester. Once we had a project design, we used Sapphira and we modeled in SketchUp to do a computed energy analysis. And then they made adjustments to their window openings and building orientation based on feedback from that program. We used sort of annotated bubble diagrams to develop our projects, and we worked very much in these sort of matrices throughout the semester. So it was always 9 or 12 or 30 of something. So this sort of idea of iteration, bringing about better results. We wanted to continue Steve's process from the prior semester. So we focused on modeling these conceptual design polarities as a continuation of 501G's focus on sort of formal architectural ideas. So you see one of the students' work there. And then I'm going to show some images from a few of the students' works from the semester. I think, I was struck by Tom's comment about the students not being hindered by new digital tools. I was challenged a little bit in selecting the students' work to showcase, because I think that for this group of students, you know, they're in their second semester of an architectural program, and I think all of the projects were really quite incredible in terms of thinking and in many different ways. I think that some of the students come in with some presentation tech skills already, and so those tend to be the projects that I select to show, but I'm not sure that they're actually the projects that showcase the best quality design thinking. And I think that's, you know, that's a little bit hard in terms of how we choose to showcase student work. So this is a project by Kate. She did a really amazing job. I think one of the complexities of the site, which I really liked, was that it has multiple approaches. And so designing a building that feels like an urban building, but at the same time responds to multiple frontages and considers how people would really arrive to this building was really a challenge. And I thought she did a really beautiful job of sort of resolving a lot of complex issues. Kyle, his previous training as a landscape architect, one thing that I thought he did really beautifully was that he created this atrium space along the canal, so that you could have these moments of sort of reflection, and that the building could be protected from the exhibition spaces could be protected from the western light, but that people in the museum would still be able to have this sort of experience of the water and relationship to the water. Also did a really beautiful job of sort of developing the approach and the sort of very specific characteristics of the public space. And then Ryan, I thought, did a really nice job of sort of resolving, taking the very analytical specific drivers of the project and really making them into this, you know, very this art museum that works very well. And he did, you know, built nice models and had a really nice project overall. These are small compositions. They highlighting work. I just knew that the full boards on the screen wouldn't be very visible, so I just pulled a few images so that people would really be able to see the quality of the students' work.
So hello everybody. So yeah, second year MArch program. This is a housing studio, and in particular, the area of investigation was on the design of housing typologies based on sort of non-standard models of home ownership. So we know that historically, there's been a really close relationship between systems of ownership and architectural typologies. And since the financial crisis, there's been sort of a renewed interest in thinking about and implementing these, let's call them, non-standard models, such as, and so I had a whole list of them, but a few of the big hitters are community land trust, which you might have been reading about recently, collectively financed and collectively built apartment buildings. And there are examples of this throughout America and Europe. And also there are other cooperative systems out there. And so the first assignment was basically, I had this list of maybe 10 of these non-standard ownership models, divided them out to students, and they basically researched a building built under these circumstances, and also diagrammed sort of who are the stakeholders involved, who are the actors, and also maybe more importantly, how does the architect fit into the system? And so the question, I think, at the heart of the studio is what kind of architecture, what kind of buildings embody these new forms of ownership? What does it look like? How is it organized? Who builds it? Who's it for? Et cetera, et cetera. And so I guess down to nuts and bolts, more specifically, the site is Red Hook in Brooklyn. And Red Hook is interesting because as sort of New Yorkers get priced out of their neighborhoods, they're moving away from the city center in search of more affordable places to live. Red Hook is under sort of immense pressure to develop. And actually, if you see here at the bottom, this picture right here where my cursor is AECOM's vision of what Red Hook should be. And I think it's funny that they show no less than 20 sort of luxury apartment towers. And so I mean, that's not personally not what I would want for the neighborhood. And so the studio is also trying to present sort of an alternative vision. So I asked the students to really think about what type of housing is appropriate for the neighborhood, what type of housing is needed, and sort of hoping to touch upon how architecture intersects with, you know, social issues such as equity, justice, social justice, and sort of housing as a fundamental human right. So I'm gonna go through two projects here really quick. This is Tao's project, really great student. So one of her basic ideas, she was really concerned with flooding. So one of her basic twists was that take the ground floors, take the square footage that a real estate developer would not deem usable because sort of, I guess, in her vision, frequent flooding, and give it over to the public space. And you can see here her floor plans and models. This was the first semester back from Zoom Studio, so I took full advantage and had them do a bunch of models, which went over about as well as you could imagine. Next is Nada and Lauren Studio, who took sort of the Red Hook's industrial past and sort of did a container project. And flip through there. So they did some manipulations to the container, which I thought was really thoughtful. Yeah, and this is the last slide showing just a series of models that I had them make for the final. And sort of, I like this slide because it sort of shows the breadth of strategies that they were able to come up with for such a, you know, a strict urban site. And I thought it was sort of refreshing. It's not just, you know, your typical apartment blocks. All right, thank you.
I taught this alongside Kelly, and Kelly and I developed all of this kind of together. And I think, you know, the topic of the studio is Fields of Play Doha, which is basically combining some of my research and interests with sports and architecture, along with Kelly's deep research and you know, awareness and thoughts on Doha in Qatar. And we thought it was just a really sort of a fantastic opportunity given the World Cup this year in Doha, and kind of trying to engage sports in a more community focused, more sort of fresh take, and try to think of how sports can be better utilized in the context of Doha. And so we started the studio with a kind of broad research into the various elements of the studio, starting first with sports. So here we had each student select a sport from a given list. We had 24 students or 25 students that had each had their own sport and did their own sort of study of its history, it's kind of like the types of players that play the sport, a study of the space of the sport, the materials of the sport, details of the sport, and then 3 analytical drawings of the sport, using kind of the tools of architecture to try to learn about the sport through a kind of spatial sense. And that was a really interesting and albeit challenging assignment for the students, but I think it kind of was very much something that I've always wanted to teach before, and it was great to have them thinking through something that wasn't specifically architectural right away. And then from there, we jumped into site research. So just one quick thing. The site is along the Corniche in Doha, which is a kind of very, very sort of prominent kind of organizational element of the city. Our site sits directly on the Corniche, and between the post office, which is the one post office for the entire country, and the National Theater and the future site of Expo 2023, and actually like a tennis complex of Doha. So with that, we had the students sort of do some very pointed research on sports in Doha, looking at different recreational centers, different, the context of the stadiums, looking at the role of FIFA and the international sporting associations related to the World Cup, as well as kind of just more typical site analysis of cultural institutions near the site, transportation near the site, kind of just analyses through various means of, because we obviously couldn't go to Doha, we utilized a lot of the like things like Google Maps and the sort of Instagram and various other ways of learning about these spaces that is a little bit atypical. But it was very illuminating, and for anyone that doesn't know, Doha is very interesting in just like a myriad ways. Just every aspect of it, culturally, historically, the built environment, it's all very unique, and I think we took a real deep dive into it, and I think it really helped us kind of learn in that research phase. Then we jumped to sorry, this is a little jumpy, but we did precedent studies of sports centers throughout the world, looking at some really sort of fantastic spread. It's an interesting type of building that I don't generally see too much embraced in a studio environment, and I think this study was also really helpful for us to learn about how these buildings are set up and how they respond to kind of the needs of the sport, but also the needs of the site and the context around them. And we for all of these this research phase, we pushed to have a very clear template. So it kind of allowed the students to just fill it in and not spend a lot of time composing, and they can just present the information. We could have a clear comparison amongst all of the projects, so using the same sort of program classifications, using the same sort of style of drawings. And I think that worked out really well. And like just the sheer amount of like the volume of the research product, you've seen it pinned up maybe in the hallway if you've been up in our studio 758. That's only like a third of it. So we're really happy with the final product there. And then I think this is also a little different than a typical studio in that we spent a good 3.5 weeks on these early exercises without specifically targeting the final project, but which kind of allowed us to really set the groundwork for an albeit really kind of complicated context and program. So from there, the final competition, the final project, and the brief is included here, was a sports center. We had the students pick, basically we prescribed 100,000 square feet of sports space, of which the students could decide which sports they wanted to use based on sort of earlier research or what they felt was most suited to the context. And then various other sort of constituent programs, and made sure to also make spectator space like very small part of it, so that we're not designing stadium, we're not designing arenas. This is very much a community sports center. It's, I guess we have a model here in the US of the YMCA, but seeing how that kind of idea and that function of a sports center in the context of Doha works. So with that, we also had the students, we focused the project around submitting to the ACSA steel design competition. So, inherent in a sports space is a long span structure, and we felt it very appropriate to fit with the requirements of that competition. And it also provided us a little bit of a, helped us hone a little bit of the deliverables, which is just 4 boards, which the students are, have been working in for the past few weeks. So I'll just run through two projects real quick to wrap it up. The first is by Libby, and she embraced really this sort of court sports and looked at this repeating truss element as something that could help frame the space, and through aggregating it, can create the building. I encourage you all to kind of zoom in and look at the renderings and sort of the detail drawings. They're really fantastic. Really awesome section here too. And then there's also Diego and Sanu's project, which was in Kelly's studio, which is purely about soccer fields and different size soccer fields, from a full size, regulation field to practice courts, and using the structure to really create the physical expression of the building. Again, really fantastic details. Both Kelly and I are really proud of the work the students did this, and I've been encouraging all of them to submit to the competition, and they have another like 3 weeks to hone the projects. And I think, from what we've seen of winners, I feel like there's actually some really great opportunities for them to win. So I hope, they keep working on it, but also like the final product we have now is still very, very clean and expressive. And I think we kind of took a step in a speculative direction at the beginning, but I think bringing it back to the steel competition at the end kind of helped congeal a lot of the ideas that we had at the beginning into a kind of legible building and final presentation.
I received some information from Caroline, who's on another final review today, about her class. She has been teaching Architecture 495 this spring semester. Importantly, she has taught the class to 8 students, and I want to acknowledge maybe, and maybe it's important for us to talk about it in the afternoon, the mix of students, right, that we have not only in the graduate program, as Carrie pointed to, and certainly Chris and I had a diversity of students in our studios, but also in this particular class at the undergraduate level. Caroline had, of the 8 students, I believe 3 who were 4th year students who were learning Revit for the first time. And then she had a number of students who are to graduate this spring. So a real mix of students, and the students worked in groups. So she had 3 groups within of the 8 students total. I was fortunate enough to attend part of the final review. I saw 2 student projects. I saw the 4th year student project, and also one of the projects that she has provided to share with you today. So these are just some pages from her syllabus. Importantly, when she was thinking about this studio, we had a discussion, and she actually focused this studio on an ACSA competition as well. So this particular studio has a focus on the timber design competition. And like many of her studios, including 505G, which she taught at the graduate level this past fall, that Gernot will talk about in a minute, has a real emphasis on not only Revit and working in groups, but also working in the cloud with Revit and using different digital modeling and database systems. So this is just a quick run through some of the syllabus that she has put together. I think that she has been focused on a project here where she's really trying to build the students' very diverse skills. They're definitely through their projects doing a lot of sketching. That's what I have seen. They're also, of course, then working in Revit and doing some analysis in Pluralsight as well. So the project brief, before I show you the final, one of the final projects, the project brief was focused again on the timber competition, timber in the city. The site here was actually in Atlanta, Georgia this year. It was a site that is essentially the air rights over the MARTA station. And it's a very complex site, an urban site that calls for a mixed use building program, 12 to 20 stories.
It was to replace the current station with a new one and a pedestrian bridge, and also expand different program components, including the introduction of an urban marketplace, short stay housing, and a community aspect or community function. So in all, on top of the transit station was an additional 75,000 square feet. And the program not only called for the design of a building, but, you know, critical arguments and approaches to thinking about different, through the lens of equity, thinking about the greater socioeconomic context and diverse users. So that's a little bit about the site. I should say that the way in which the grading broke down, I believe she had 20% of the grade focused on the midterm, a series of online discussion assignments that were worth 30% that I'm not really that familiar with, unfortunately. And then the final project was worth 45% of the final grade. And this is a project by a team of 2 students who you may know, Peter Zhang and another Peter, Kozarski. Like the project that you just saw Chris present, the ACSA competitions, the deliverables are 4 20-inch by 20-inch boards, so the real estate is very limited. These are the 4 boards for these 2 students, and I'll just go through them here. So here you can see the approach to the site. We discussed how plans incorporated in these diagrams would be very beneficial moving forward, because like our students in 504G, these students will continue to work on the competition entry for the June 1st submission deadline. The different aspects of heavy timber, this very unique idea or iconic idea of the kind of branching of the structure. And lastly, the site plan and views of the interior. So I will end there and turn it over to Gernot to talk about 505G.
So 505G is the equivalent in the graduate program of Advanced Architecture Studio 1. And I will share the syllabus. So syllabus is very similar to the undergraduate version of the of Advanced Architecture Studio 1. The workflow is really also, it's very heavy, like on sketching in the at the beginning of the semester, but then going very quickly into Revit and into all kind of simulations for feedback. So there's a lot of kind of feedback loops, simulation, analysis, revision, different iterations, and then final presentation. I want to share one project here from that studio. So the program of the studio was a hotel. The students were able to pick their own site. So that was also at the beginning of the semester, the discussion of like which site to pick and then how to respond to different contexts. And then the hotel sort of picks up, on a housing project, because you have like rooms, you have some that you can aggregate. So I think it was a very appropriate program, especially with going into Revit and going into building information modeling. And so this is one of the projects from that studio. Interior renderings, site section, and other renderings. With that, but I just received the the syllabus and one project. So that is it.
I represent 5 different studios, both graduate and undergraduate level, of a lot of very hardworking faculty and students, particularly because the Advanced Studio 2 is unique in a few ways. First of all, the students get the sense, and as the faculty do, that it's the opportunity to show everything they know and everything they can do at one time, because it is in fact kind of the culmination of their previous background and education. Another aspect is that they're being asked to show what they know and what they can do in terms of design individually, although in many of the studios they're working collectively with either research or in discussion groups. So we are continuing with the same project that we've done previously. However, we've made the site, we've adjusted the site to another location, which is a little easier to deal with. It's a bigger site. We have 4 very direct and simple program elements: 4 galleries, a rear book library, a cafe, and an entrance hall. The site is located, as you can see, on Roosevelt Island. It relates to the transition between the Cornell Tech Campus and the South Park and Lewis Roosevelt Memorial. The studio aspect of this is asking the big questions, like how sophisticated and significant are the conceptual and theoretical intentions of the design? How difficult or how much risk has the student engaged in the design? How does the design concept and technical development relate to contemporary architectural thought? Is there a general consensus that the proposed design is architecture with a capital A? Now, so studio is trying to continue with the same general objective as all the previous objectives, and obviously overlay a whole variety of other questions, some coming from the NAAB, some coming from other coursework. Fundamentally, we're asking the students to look at the design in 5 or 6 different scales. Our site is within Manhattan, it's within the river, it's within the island, it's a building, it's a set of rooms, it's a wall construction, it's details that are associated with it. And it's also quite newly for many of the students, the need to make the building perform in terms of energy analysis and also in terms of carbon footprint. I'm going to talk about the work in the graduate studio alone. Of the students, only 1/4 of those students had actually had previous skill using Revit to the level that you could say that they have introductory skill. And none of the students had previously analyzed the building in terms of energy response or carbon footprint. So for a lot of students, they were simultaneously dealing with the gaining of the skills of being able to deal with the construction of Revit, both as an architectural device and an analytical device, and also dealing with analysis for to a large degree for the first time. The other side is the seminar, which is, as you I'm sure are all aware, addressing 10 criteria. The red text is what the NAB gives us. The dark bold is our faculty's interpretation of what would those subcategories be, and then to try to translate what those subcategories mean to a student operationally in terms of, as a student, what do I do? What answers do I give? What do I think about? We've posed a series of questions for them to address. And the design project itself is written very, very specifically. Each program element has a rather lengthy set of criteria by which our client is asking that the spaces be developed. We have created our own zoning requirements. We have our own site conditions, including subsoil conditions. And of course, we have our own the need for climate analysis, site analysis, and all the things that really the previous studios are addressing. I'm going to show you just one example. The final presentations are either done through projection or they're done through board on the wall. If they're done through board on the wall, they're generally at the scale of 6 or 7 feet tall and 15, 16, 20 feet wide, or they are shows of about 150 to 160 pages. So they are, by their own nature, comprehensive, because the paradox is we're giving them a reasonably limited amount of time to address a whole variety of issues. So if you look at it from the point of view of all the previous coursework we just saw, if you ask the students to do all the assignments they did in office practice, structures, construction, ECS, and history, and said apply some of that knowledge to your design work, you can kind of imagine the scope of a project that they're addressing. So obviously the goal is to try to integrate all of that knowledge together into a comprehensive building, which we would like to say is both buildable, efficient, and something everybody wants to build. New this semester is the energy analysis, the insight energy analysis, going from all the way down to being something between, approaching AIA 2030, which for many students is quite a challenge. And then another thing that's new this semester is looking at least one component of the building and comparing different choices in materiality and construction to ascertain the carbon footprint and the effect upon the environment. So these are just some examples of parts of the work. So what distinguishes the students' work from earlier semesters is, one, they're working alone or producing their own design project with their own design ideas, and fulfilling the obligations of the NAEB 10, as we call them, and obviously all the other issues that are associated with architectural studio.